Thank you for having me back, Fused. We've made some progress over the last month on the crop yield prediction model, and we're prepping the model data set. So this is the really exciting part. When I started as a geospatial data scientist, I really wanted to build models, and excited to share. First, I want to share a little bit of scenes from the Scholten family Thanksgiving. I went to a farm sale. We went, it's really interesting how it happens. I was really curious about how farmers make decisions on data, right? We're all geospatial data scientists here. We have a lot of information about our Earth, but farmers don't necessarily have that information. And what data are they using to make that? So I went with my brother. We got in the truck. Everyone stays in their truck. They bid from their truck, and it's a live auction. And you bid on the price per acre. So beforehand, we did a quick little analysis of what is the value of this land based on the productivity of the crop. And that's what I want to try to get to. I want to try to be able to predict corn yields in season. And the yield is measured in bushels per acre. Hold up. What is a bushel? A bushel is actually just a unit of measurement for like a bucket. You can think of it as like a bucket of corn, 56 pounds, or for the metric system people out there, 25 kilos. Okay, now what's an acre? Well, an acre is about the size of an American football field. Sorry, I don't have another reference for European, but if you think about American football field, it's a certain amount of square feet and square meters. So if I say I have 150 bushels per acre of my corn, you can imagine 150 buckets of those 56-pound buckets on a football field. And this has been tracked and measured by the USDA over the last 30 years. And this is what it looks like. You can see there's a strong linear upward trend based on improvements in how we manage our crops, seeds, fertilizer. It's very, very dependent on rain. A lot of the different variables go into corn yield. And where I want to predict is within the growing season in June. So corn is typically planted between April and June, depending on when it rains or what the weather's like. And then it grows throughout the season and is usually harvested by November. And I want to be able to predict in June area. And the variable that I've been using is solar induced fluorescence. And this is kind of a new variable. It's a bit untapped because it's a very innovative research and it requires very special cameras to be able to measure this variable. So solar induced fluorescence is a direct measurement of photosynthesis. You can think of it like a heart rate monitor for plants. It's not an image. It's taking after plants do photosynthesis, they emit a soft red glow, and that can be measured by satellites in the sky. And because satellites are so far from the Earth, the data ends up being really coarse. So we can only do it at 25 kilometers squared today, which is really big when you think about a lot of our Sentinel data is at 10 meters or 30 meters squared. So when we look at SIF within the season of a particular year, and we compare it to the actual yield of that same year, you can see a strong correlation just by looking at the map. There's very fertile soil in the Midwest, and it leads to high corn yields. So I want to do this for all the corn in the Midwest. There's about 90 to 100 million acres, 1,300 counties, and it's about a $21 billion industry. The reason I say counties is because that's what my actual variable is at, as you saw from the other slide. So we've seen in the past, we were able to actually mask the areas of SIF for only the areas of corn. if we looked at the previous slide was doing everything. So we were getting towns, buildings, trees, but I only care about where the corn is growing because I want to know what my bushels per acre of corn is. So we did this really great mask with Fused. I haven't seen it done anywhere else. Didn't know it was possible, and really happy with being able to mask these corn areas for these roughly 1,300 counties in the Midwest. Now, before I get into the actual model data set, I wanted to quickly shout out people who really helped me this month. The Fuse community is a great one. Planino, Gabriel, and Claudio really helped me in setting up my model specifications. And I actually got the opportunity to meet Claudio in person. So that was a delight. So I have 4 SIF measurements for the years 2015 to 2020. So I'm taking May, early May, late May, early June, late June. And if I do a quick SketchUp of what I want the model data set to look like, I want to have my key variable be county. And then I have, for each year, I have a yield. I also have an area of corn, area of the county. This is measured in acres. And then I have a percent of corn and percent of county. And then I have SIF for each of those. So I was actually able to do this using DuckDB in Fused for all those years, all those counties, using both SQL and Python objects. And that is my model ready data set. And I'll be looking for partnership for building the actual model. So excited for that. Thank you.
Thanks, Kristin. That was great. I really like your analogy of a heart rate monitor for plants. I think that really helps stuck it in my mind. So you grew up in a farming family, so I'd be interested to know, what lessons from that do you carry into the world of data, particularly when you think about designing data products for practitioners in the ag industry?
Yeah, I find it very useful. I was actually looking through some of the data with Planino, and we noticed like a really high yield in Idaho. And based on my experience, my dad was telling me they use a lot of irrigation in Idaho. So those are some of the considerations that we need to make. And it's helpful to have that farming background to know that, oh, they have irrigation systems. They're not dependent on rainfall like the other counties. So yeah, it's very helpful.
Thank you. That was a great presentation.